So after we've got vertical asymptotes and we've got our x-intercepts, the third thing for us to find before we start trying to draw our graph is the horizontal asymptote. Each graph will only have one horizontal asymptote, and just like the vertical asymptotes that kind of help guide the shape of our graph, the horizontal asymptotes help guide the shape of our graph, but especially as we go out towards infinity on either end, kind of like when we talked about end behaviors a few chapters ago. So the horizontal asymptotes basically just determine end behaviors. So let's look at the horizontal asymptotes on these examples. On this first blue one, we would have a horizontal asymptote going across here. It looks like that's maybe at y equals 1. On the red graph, we would have a horizontal asymptote at y equals 0. Note that the red graph, it gets real close to that horizontal asymptote. As we go out really far to the sides, we get really, really close to that asymptote, but it never actually gets there, and we'll kind of see why that is when we see how to find the horizontal asymptote. Over to the green graph, y equals 0 is our horizontal asymptote again. And here's what can be tricky, I think, with the horizontal asymptotes is that the rule or the behavior of it being an asymptote can kind of get broken in the middle of our graph. Okay, the horizontal asymptote really has to do with what's going on really far out on the sides. And so there might be cases where we don't have, or in the middle, we might go through that horizontal asymptote. Now that will for sure never happen with a vertical asymptote. We will never go through a vertical asymptote. But in the middle of our graph, the horizontal asymptote doesn't really mean as much. Okay, so that just might throw you off here and there. The other thing that can throw you off about a horizontal asymptote is our horizontal, and I'm saying that with air quotes, but you can't see me, that our horizontal asymptote might actually be diagonal. And this is my least favorite scenario. There's a little bit more thinking that we have to do to try and figure that out. But we might have an asymptote or end behaviors that aren't horizontal, and it actually follows some diagonal line, but that will still help us draw the graph using that asymptote. So there's three possibilities when it comes to a horizontal asymptote. And to determine what it is, we're going to look at the degree of the numerator and denominator of our function, of the top and the bottom. So hopefully remember that degree just means the highest power that we see in that polynomial. You maybe want to pause this and jot this down somewhere. This is going to be useful to reference. Okay, but we compare the degree on top and on the bottom. If the degree on top is smaller than the degree that's on the bottom, our horizontal asymptote is y equals 0. The reason for that is, let's say we have x on top and x squared on bottom. As we go out towards infinity, x is so much smaller than x squared that x divided by x squared is practically 0. So as we go out really far, we get closer and closer to 0. Okay. If the degrees on top and bottom are the same, if it's x over x or if it's x squared over x squared, we divide the leading coefficients. Okay, because if they're the same, then they're the same size as we get out to infinity. So we take the number at the very front, so the coefficient, the number at the very front of each of those expressions, and divide them. And that's how we get the horizontal asymptote there. The other case is that the top is bigger than on the smaller. And again, that's our least favorite case. That's the one where we end up with more of a diagonal asymptote or end behavior. If the degree on top is bigger, so let's say we have x squared over an x, we divide the leading terms. So we would take the coefficients, but also the x's with those and divide those, and it's going to give us probably a line for, so like a y equals 2x for our horizontal asymptote. We'll get to see each of these cases in the examples we're about to look at. So y equals 1 over x. For our horizontal asymptote, we compare the degree on the top and the degree on the bottom. We don't have an x on top, so this is really like having an x to the 0. And down here we have an x to the first. So the degree on top is smaller than the degree on the bottom, which means that our horizontal asymptote is y equals 0. Hopefully that's pretty easy to see, just that as we go out towards larger and larger numbers, 1 divided by those large numbers is going to 0. So our horizontal asymptote is y equals 0, so just along the x-axis. For our next one, we have x over x squared minus 4. So again, the first thing we do is compare the degrees. So we have x to the first on top, x squared on bottom. So it's smaller on top. So I think that's our nicest case, because again, that just means that y equals 0 is our horizontal asymptote. Okay. Next case, we've got x squared over x squared. So again, we don't care about these. All we care about is the degree, so the highest power, the terms with the biggest exponent. So here we have the same, okay? We've got the same degree on top and bottom. So we consider the leading coefficients. So on top we really have a negative 1 x squared, and on bottom that leading coefficient is a 1 x squared. So we take those leading coefficients of negative 1 over 1, and so y equals 1, or sorry, negative 1 is our horizontal asymptote. So at negative 1, there is our horizontal asymptote. Now our last case, the least convenient, is when the top is greater than on the bottom. So here we have x squared over just an x. Okay, so it's bigger than it is, or bigger on top than it is on the bottom. So here we take the leading terms. So the leading terms are x squared and x. And if they had numbers attached in front, we would bring those with. But here, our horizontal asymptote is going to be y equals, and we divide the top leading term by the bottom leading term. So y equals x squared over x, which would reduce to just an x. So our horizontal asymptote, or our end behaviors, are going to be the same as the diagonal line y equals x. Okay, so horizontal asymptote I think is the worst part to deal with. But now that we have all these done, we're ready to start piecing together what the graph actually looks like. So we'll do that in the next video.